Hi all, my name is Praveen Kumar. I'm a specialist solutions architect at AWS, and I specialize in data and analytics. In my role, I help customers design and build modern data platforms and help implement diverse use cases such as big data and processing, business intelligence and reporting, interactive analytics, and streaming applications. In this session, I'm going to cover how to extend and scale your analytics architecture and applications in the cloud. So if you are a customer who has migrated the first workload to the cloud and are wondering what's next, then this session will provide you an insight to what that journey looks like. Before I get started, let me walk you through the agenda for this session. I'm going to start by providing an overview and talk about current industry trends and big data challenges. Next, I'll cover AWS recommended architecture for data platforms, and we'll share a few best practices. And then I'll talk about a scenario where a customer has migrated their first workload to the cloud, and I'll present their platform architecture. This architecture will form the baseline. Then from there, I'll talk about a number of analytics use cases, and we'll see how the architecture can be evolved and scaled to meet the needs of the various user personas. Finally, I'll provide a summary, and we'll wrap up with next steps. Let me start by sharing the core message that I want to convey today. In our discussion with customers who have migrated their data platform from on-premises to cloud or are in process of migrating, we often see that customers tend to favor a lift and shift approach, and they carry on-premises thinking when designing solutions in the cloud. And this may not seem problematic at first. However, with time, as they scale and diversify their workloads, they start seeing similar types of limitations and constraints that they have witnessed while on-premise. To avoid this and to ensure that customers continue to operate and manage a platform which is highly performant, efficient, and cost-effective, let's now look at some of the approaches that you should consider when designing solutions in the cloud. So first off, starting with the right foundation and architecture is one of the most important components for ongoing success. Secondly, using right tool for the right job will help maximize the value and performance from your platform. As what we see is a one-size-fits-all approach inevitably leads to compromises. Next, adopting an experimental mindset and being curious will help leverage the most advanced features and latest cloud innovations. And finally, thinking beyond today and in a way future-proofing your platform. Now, by following these guidelines, and this has been my own first-hand experience, customers will see a significant increase in business agility, improvement in operational efficiency, and significant reduction in run cost. And let me give you some data points. In one of the migration projects that I was involved in, we achieved 80% reduction in operational run cost, reduced deployment cycle from 1 month to 1 week, and reduced ETL duration from 8 hours to 1.5 hours. Now, before I talk about the customer journey and a number of use cases, let's look at some of the current industry trends and big data challenges. Data is growing at an exponential rate. Today, more data is generated every hour than entire year of data just 20 years back. The data could be from organizations' existing sources, such as ERP, CRM, and other business application systems, or it could be from other diverse sources, such as sensor devices, mobile apps, application logs, social media feeds, and so on. As data is the core strategic asset of any organization, it is increasingly important for businesses to capture and analyze all of the available data and then be able to generate insights in a timely and reliable manner. Next, we are also seeing an increase in the types of user personas who would like to interact with the data platform and access information using their own tool of choice. For example, data engineers like to use an integrated development environment for building data pipelines, whereas a dashboard user prefers an easy-to-use data visualization tool. Then you have a data analyst or line of business user wanting to use an interactive query service. And then we also need to find a way to send data to downstream application for that insight to action. So the needs are quite diverse. And finally, we are also seeing an increase in the business demand for real-time streaming applications. The common use cases are real-time fraud detection, application monitoring, clickstream analytics, and live leaderboards. These real-time applications enables businesses to access information faster, and it accelerates decision-making process. So what's happened over the last number of years is that as organizations have grown, so have their application footprints. And in the process, customers have accumulated a lot of data. However, most of this data has ended up in different data silos. Now, this has created a new set of challenges and problems. First, customers cannot get a complete view of their data. And in order to get the consolidated view, data needs to be extracted from these various silos, then needs to be cleaned, combined, and then aggregated to get the final output. This process could be quite manual and error-prone, which often results in data quality issues. Also, data silos hinder organizations' data collaboration initiatives and results in duplication of effort. To solve for this, customers are looking to move all of their data from various silos to a single and unified location, which is commonly known as data lake. Data lake is highly scalable, available, and secure data repository that allows you to store all your structured and unstructured data at a low cost. So we are seeing more and more customers migrating to modern data platform with a centralized data lake that can support diverse analytics and machine learning needs. Now, when it comes to choosing infrastructure storage layer for data lake, Amazon S3 is a very popular choice among our customers. We have tens of thousands of customers using Amazon S3 as the data lake for its unmatched durability, high availability and scalability, and industry-leading performance and security at low cost. And then with this S3-based data lake, you could use a broad and deep collection of purpose-built data services on AWS that's optimized for use cases such as interactive dashboards, big data processing, machine learning applications, and real-time analytics. We call this modern cloud-based architecture as the lakehouse architecture. Now let's look at some of the best practices and guiding principles of a cloud-based modern data platform. So the best practices that I'm going to cover today are a set of guidelines that I've seen working well in the cloud. And this is through some of the successful implementation projects that I've been part of and through my own learning over time. First, I'll talk about extensibility. As you migrate or extend applications on the cloud, you need to ensure that your platform architecture remains flexible, is cost-effective, and performant at all times. For example, you may have an ETL framework to use BI cluster for processing all of your data. However, in future, if you have to process high-volume application log or telemetry data, a more cost-effective and efficient option would be to utilize a distributed processing engine, such as Apache Spark on our managed service Amazon EMR to get the best value and performance. Next is open formats. You should consider keeping data in open formats, and you should look to utilize open source framework on our managed services such as Amazon EMR for building Apache Spark and Hadoop applications, or Amazon Kinesis Data Analytics for building Apache Flink-based streaming applications. This approach has a couple of key benefits. First, it allows for portability and helps avoid proprietary lock-ins. Second, you can take advantage of innovation within open source community. For example, you could use popular open source frameworks such as Apache Spark for big data processing or Apache Hudi to simplify incremental data processing and data pipeline development. Next is automation. By automating tasks that is currently manual, you can improve operational efficiency, increase agility, and reduce development effort and deployment times. To that end, you should consider automating tasks such as code release and deployment, backup and recovery, regression testing, and monitoring and alerts. Next is reusability. Reusability enhances the productivity and improves the quality and reliability of your platform. So you should look to utilize infrastructure as code as much as possible to set up environments and spin up clusters on demand. You could also implement metadata-driven ETL framework to reduce the amount of code you have to write for ongoing development. Finally, decoupling. Decoupling will help reduce application dependency, will improve resilience, and increase scalability. For example, by separating a storage from compute, or by separating different stages of your data pipeline, you can appropriately size your workloads and achieve best price performance. Now we'll consider a scenario in which a customer has migrated their first workload to the cloud. In this case, it is a BI and data warehousing workload. On this slide, I have the reference architecture of the customer's platform. The data is ingested from a number of source systems to Amazon S3, and then they use Lambda to copy data from S3 to Redshift. Following that, they run data processing jobs using the BI cluster in an ELT framework. And finally, end users access this same cluster for reporting and dashboarding needs. This customer has engaged us, as in AWS, to provide a point of view on their current setup and architecture, and wants us to help them scale their data platform using best practices. Following that, we organized multiple workshops with their data platform team, as well as multiple line of business users to understand the current challenges and use cases in more detail. The reference architecture on this page will form the baseline. And in the next few slides, I'm going to talk about a number of requirements focused on analytics use cases. For each of the requirement, we will look at the solution options and design patterns by working backwards from the customer's need or pain point. Let's first look at the various user personas that we are going to cover today. On the left-hand side, I have members from the platform team. So we have a data platform manager and data engineers who are collectively responsible for platform design, development, and administration. Then we have a data steward who looks after data governance, data security, and data quality. And then on the right, we have line of business managers who lead procurement, customer experience, and plant maintenance functions in this organization. So here is the first use case shared by the data platform manager, and he would like us to suggest solution to some of their current challenges and pain points. The manager would like to know, how can we reduce the resource contention on the BI cluster with ETL and reporting workloads running together? The manager has also received requests from sales, finance, and data science teams to have their own BI cluster. This setup will allow these teams to develop their own data models without having to rely on a centralized IT team. The data platform manager wants to know how this setup can be achieved without having to copy data from a central cluster to multiple line of business BI clusters. He would also like to know if he can implement the chargeback model for these clusters. Finally, he would like some recommendations on improving ETL duration. Now let's look at the solution options to achieve all of this along with her reference architecture. As you can see, we have introduced a few changes to the baseline architecture, which is indicated by the red asterisk sign. The first change is to decouple BI and ETL workloads, which should remove the resource contention. The decoupling has been made easier by the recent release of Redshift data sharing. Data sharing in Redshift allows you to securely and easily share live data across Amazon Redshift clusters without the need to copy or move it. So in this case, you will run data processing jobs in the centralized ETL cluster, and then processed data can be shared with various BI clusters as required. This change also allows you to appropriately size up the cluster to get the best price performance, and will enable you to implement chargeback model. We have also introduced Amazon Athena for running interactive query directly on top of S3. So for users who want to explore new data feeds or want to query raw data, they don't need to use BI cluster or write ETL jobs. Finally, we have introduced a processing layer for data lake, and this will allow you to process data using a right tool or framework. For example, if you have to process big data sets such as application logs, or sensor data, you can utilize distributed compute engines such as Apache Spark on EMR. And if you have flexible processing SLA, you can use EMR spot pricing that can be up to 80% cheaper compared to on-demand instances. And let's say if you have to process unstructured data, you can use one of the AWS fully managed machine learning service, such as Amazon Comprehend, Textract, and others to process that data. Next, we'll cover the use cases of the data steward. Currently, the data steward has to write and execute SQL queries every day to monitor the quality of the data. This process is quite manual and time-consuming. So he would like to know if there is a better way to achieve this. Also, he would like the data quality validation rules to be built as part of the data pipeline process. So in case if there is an issue with any of the critical data sets, the data pipeline should not progress further, and an alert should be sent to all the relevant parties. He would also like to know if he could access a dashboard with data quality statistics that gets refreshed every day based on the new incoming data. This will help him improve the trust and quality of the data. Let's take a look now how this can be achieved. In this architecture diagram, we have added a new service in the processing layer called AWS Glue Data Brew. AWS Glue Data Brew is a new visual data preparation tool that makes it easy for data analysts and data scientists to clean, transform, and profile data without the need to write a single line of code. Glue Data Brew can also be used to run profile jobs that auto-generates 40+ data quality statistics such as missing and duplicate values, average, median, maximum, correlations, and so on. For the data steward use case, you can use a Lambda to trigger a data profiling job to generate key statistics on the data set. And then we can build validation rules using another Lambda to trigger notifications when the output metric exceeds a threshold. For example, if the data set has 1% missing data for a particular column, then send me an alert. The profile data that's generated is in JSON format, so we could build a dashboard on top of it for increased visibility. Finally, we have added another layer in S3 for storing curated data, which in this case is profiling jobs output. Now, here is the screenshot of various components of an automated data profiling job. On the top section, we have the output from Glue Data Brew profile job that you can view using the AWS console. Below that is the code sample, which contains data validation rules and thresholds that you can write using Lambda. And in the lower right section is a sample notification email that can be configured using Amazon SNS service. This end-to-end pipeline is very simple and easy to set up using AWS Cloud Native Services. Next, we'll talk about two use cases which I have grouped together as both involve processing unstructured data and have similar design patterns. First use case is for a procurement team who currently spend a lot of time and effort in manually processing hundreds of invoices every day from suppliers. These invoices could be typed or could be handwritten. The team has to extract key information from these invoices and then enter it into an ERP system. So the procurement manager wants us to advise if there's a better way to achieve this. In the second use case, the customer experience manager wants to know how their own end users are reacting to a product or service launch. She would like to have a dashboard to monitor sentiments from the social media feeds and also be able to access key information such as places and brands included in the feed. Let's see how we can achieve these two use cases by utilizing two fully managed and cloud-native AWS AI services. As you can see in this slide, we have added two new services in the processing layer. The first one is Amazon Textract. So Amazon Textract is a fully managed machine learning service that can be used to extract text from scanned documents and images. you can use Lambda to run a extract job with just few lines of code and schedule it as part of your data processing pipeline. Next, we also added Amazon Comprehend, which is a fully managed natural language processing service that uses machine learning to find insights and relationships in text. You don't need any machine learning experience to be able to use this service. The service can do sentiment analysis and can be used to extract key information such as places, people, and brands from the text data. Again, you can use Lambda to make an API call and pass text data stored in S3 as input and get the results back. For example, you can run an Amazon Comprehend job on text data to determine if the sentiment is positive, negative, neutral, or mixed. And then this processed data can be aggregated and visualized using a BI tool. In both the use cases, we just had to extend the existing pipeline to include additional services, and it was quite seamless. Let's talk about our final use case, which relates to proactive monitoring and plant maintenance. The manager would like to get real-time notification when sensors placed on the equipment record a series of high temperature in a fixed time window, for example, 30 seconds. She would like to get notified in real time so that she can initiate investigation and do proactive maintenance before the equipment fails. She would also like to retain this data for historical reporting. Let's look at how we can achieve this. This problem is related to real-time analytics use case, and so we have extended the architecture to include streaming services. We have used Kinesis Data Stream and Kinesis Data Analytics for ingestion and processing of sensor data in real time. Kinesis Data Stream is a fully managed real-time data streaming service that can continuously capture gigabytes of data per second from hundreds of thousands of sources. Once ingested, we could use Apache Flink on Kinesis Data Analytics to perform a stateful stream processing. With Amazon Kinesis Data Analytics for Apache Flink, you can author and run code against streaming sources to perform time series analytics, feed real-time dashboards, and create real-time metrics without managing the complex distributed Apache Flink environment. After processing, we can send the data to another Kinesis data stream, and then Lambda can consume this data and send notifications in real time. We could also use Kinesis Data Firehose to deliver streaming data to S3 and retain this data in one of the low-cost S3 storage tier for historical reporting. So let's summarize what we have done so far. We started with a baseline reference architecture for a BI and data warehousing workload that needed to scale. Then we spoke to various stakeholders in the organization, including the line of business users, and gathered a number of use cases. Then for each of those use cases, we worked backwards from what was required. We explored various solution options. We identified the right set of services, and then seamlessly extended the architecture to implement each of the use cases. We also ensured that our architecture remains flexible as we scale. And that allowed us to leverage latest cloud innovations such as Redshift data sharing and Glue Data Brew. So as you can see on the left section of the slide, we just had a BI workload when we started. However, we have now extended this platform to run a variety of workloads with best practices built in. We have implemented batch processing. We have used machine learning services to process unstructured data. We have built a streaming application, and we have also implemented data governance use cases. This platform is well integrated, and we have been able to leverage the full capability of AWS Cloud Native ecosystem to provide the best value and performance. So let's talk about the next steps now. If you'd like to have an in-depth discussion on anything related to the use cases, architecture patterns, or best practices that we have covered today, our team would be more than happy to speak to you. Also, if you are currently considering migrating your data platform to the cloud and would like any guidance or support, please reach out to our team at the email address mentioned on the slide. And one of our team members will get back to you soon. Now, here are some of the resources that you can use to learn and understand our services in more detail. We offer free digital courses that cover a range of AWS analytics services such as Redshift, Glue, EMR, and so on. We also offer classroom trainings to learn from the AWS expert instructors. We offer a number of certifications, including one on data and analytics. And finally, you could access resources such as blogs, white papers, tutorials, and technical talks on our website for deeper understanding and knowledge. That wraps up my presentation today. I would like to thank you for your time, and I hope this session has been useful for your data and analytics initiatives, and it will help how you think about designing workloads for the cloud. Finally, we would really appreciate if you can fill up the session survey so that we can better understand the topics and services that you would like to know more about. Thank you for watching, and have a great rest of the summit.